All right, guys, in 381, remember this lesson is not going to be quizzed over, but you will see a potential question off of this lesson from your test or on your test. So, we're talking about arithmetic and geometric sequences. Specifically in 381, we'll be talking about arithmetic, okay? But you'll see me make reference to the geometric because that's coming in 382, okay? And it's just easier sometimes to talk about the two of them together than as opposed to being separate. All right, so arithmetic sequences are linear functions that have a domain of positive consecutive integers. So 1, 2, 3, 4. So the x values are 1, 2, 3, 4, all the consecutive numbers positive going forward. All right, which makes them a little different from a regular equation or function because you can't do negative values, you can't do decimals. Like it's strictly limited to first term, second term, third term. So positive consecutive integers. So the next thing is that they can be represented by formulas, explicit or recursive, and the formulas can be used for certain terms of a sequence. The explicit formula is a formula used to find the nth term in the sequence. Recursive is basically used to find the next number in the sequence. We talked about that a little bit before. And the explicit is going to be used to find any number in the sequence. It's more like a traditional function or equation. Okay, more like your slope-intercept form, y equals mx plus b. It's just a slight variation. Okay, so moving forward here. So I would copy this down. This is a comparison chart, if you will. So for an arithmetic sequence, the thing I want to pay attention to is for the recursive formula, the important part is that it deals with the term that came before it. Okay, so a sub n, the term you are currently looking for, right, is a sub n minus 1 plus your common difference. So it was written here, but if I'm looking for a5, then I would do a4 plus my common difference. And now your common difference could be negative, so in that case it'd be minus d, because you're adding a negative, so that becomes a minus. But either way, it's still, that's the basic generic formula for writing it. Okay, so this means the term that came before. Okay. All right, and then the recursive, and then the explicit form, the closed form, is down here. This is more like what you're used to with a function. Now, what I want to point out from this is notice that we normally start with our y-intercept. That is the first term, not the y-intercept. Okay? And we talked about this with exponentials a little bit before, so this shouldn't be new to your brain, this idea up here, okay? To compensate for the fact that we're starting with the first term, right? The first term instead of the zero term, or your y-intercept, we have to account for that by, instead of x, we're using n here, but we subtract 1 from our n value, our x value. We did that with the exponentials before. We talked about how you could write the same function using the first term instead of the zero term. And then our common difference, that's just your slope. Right? It's the thing that you're repeatedly adding or subtracting by. Okay? So this, even though this looks a little bit weird, it's actually not that bad. Okay? And then over here, geometric, we'll talk about more in the next lesson, 382. But basically what you'll notice is the recursive form is the previous term, and I use g sub n here instead of a sub n, but it works the same way. I use g because why? It's geometric, right? They can use any letter they want to. They probably will use a sub n. They also could do f of x. So the term you're looking for, which is g sub n, is the previous term times the common ratio. Remember, geometric exponential function is repeated multiplication. All right. So g sub 3, all right, g3 would be, I don't know why that's there. Let's erase this. Can't erase. All right, we'll try a different way. So G3 would be G2 times R. Does that make sense? Hopefully so. It's the previous term, it's the term that came before it, times the common ratio. Okay? And for explicit, we're going to come back to that exponential idea and that n minus 1 or x minus 1 idea. So it's not the first, it's the first term. First term, not the zero term. So therefore, you can't use a times b to the x because you're not doing a sub 0. You're not doing the initial value, right? You're doing the first term. You're doing the next value. So you're talking about a1, right, instead of a sub 0, or in this case, g1. And then to account for that or to compensate for that, when you do the exponent up here, instead of just having x, you have x minus 1. So basically, you're going up by 1 in the initial value, but you're going, or up by a term, and you're going back a term in the exponent, which kind of cancels each other out, if you will. It makes them be the same equation still. All right, so let's look at some examples. All right, so example 1 says, find the common difference, write the explicit formula, and find the 10th term for the following arithmetic sequence. All right, so our formula here is a sub n equals, right, a1 plus, and the way it's written in your on your formula sheet is n minus 1 times d. Don't ask me why they put the d at the end, okay, because it's really just a distributive property. It's the same thing as writing it this way. And again, don't ask me why they do that. Don't ask me why they put the d after on the formula sheet. I really don't know. Maybe that's something they'll fix this year before the milestone. I'm not sure. But it's those two things, they mean the same thing, because remember, multiplication is commutative. So we start by plugging in what we know. This is explicit, so it's pretty easy. First term, 3, right? Plus, now my common difference is, okay, well, how am I getting to each term in the sequence, right? So I can do it two ways. I can do a2 minus a1, or I can do a3 minus a2. I can pick any two numbers that are consecutive in the sequence and subtract, right? And do the second one minus the previous one. So 9 minus 3, or I can do 15 minus 9. And because it's arithmetic, it should be the same value each time. So in this case, that is 6, and of course that is 6 as well. So my common difference is 6 to the n minus 1. Basically, this is your y, right? This is your y, and this is your x. Okay, n is your x value. So it's kind of like that, you know, f of x equals 3 plus 6 times x minus 1, right? That would be the function notation version of that equation. And of course, if I want the 10th term, right, f of 10 would be 3 plus 6 times 10 minus 1, which is 3 plus 6 times 9. 6 times 9 is 54. So that'd be 3 plus 54, which is 57. Okay? And I can find any term in the sequence using that. All right? So I'll stop this video there. Then we'll do an example 2 and 3 on the other one. Then we'll move to 3, 8, 2. All right?